This thing on? Huh? Is this working? I think it's working. So, yeah, look a little different. It's okay. Today we're gonna do some old school tear apart your own crackme because you forgot how you made it way back 13 years ago, and hopefully make a self keygen out of it. So we're gonna use olly today, and I'll show you why in a minute. Why we're not using X32 or X64 DPG. The reason for that is I'll show you. So first, let's go ahead and open on the desktop, I believe is where I put it. And that's going to be number 3, I believe. I think it's 3. It's either 3 or 2. Can't really remember. Pretty sure it's 3. No. The reason I went ahead and picked up olly today is because help on command, for example. We can go to help on command and get this nice little blurb right here that says what the command is, what the hex dump of it is, and what it does. Very simply put. Whereas, for comparison's sake, this some work, I'll say. It's definitely lacking in the help on. So we were looking at not NTDLL module. Damn it, module. And it was like a, something like. Actually, we'll get down to the nitty gritty. Copy address, go to address. Okay, so let's do help on mnemonic. Ready? Okay, so we get this giant ass page of God knows what. It doesn't put you in the right spot. First, we gotta scroll up. And let's see. Compare two operands. Okay, so it gave us every opcode of what it is, the compare, then it'll show us how it's made, and then it gives us a giant description, and then everything else. And it's like, man, that is annoying. Couldn't you just give me a little blurb like this? Just like this. Instead of this giant thing. It literally just dumps that section of the help into the log, and I hate it. Okay, anyways, so back to olly for today. I'm getting some messages. RDP. Remote desktop. All right. And use. He makes it in. See him. Anyhow, so here we are. And here's our C exit process. Here's the call above it. I'm gonna hit enter, and this is where our code begins. And we'll see that we have this strange thing here. Keep that in mind. There we go. So let's see. Yeah. So we started here. Wait, is that where we started? Started right here. And let's see what happens, because that's the beginning of our code. Let's hit run. Boom, we're here. And just click here. Okay. Alright, so push EVP, move some stuff, blah, 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 blah. Then it's going to do a call. There's a call to here. That's strange. Compare EAX 100. Doing some stuff. That's going to jump to, let's do an F7. See what that is doing, because that is doing some stuff. Okay, so let's see what this is doing, because it's pushing ECX, which is, well, this address here. Let's follow, let's copy the clipboard that. Oh, I see, it's just storing ECX. Just gonna keep track of it, put it back probably. Okay, so move ECX ESP, that's top of the stack. So we'll hit F8 and add ECX8. That's gonna move us up. Here, compare EAX with 1000. 10, jump it below. Subtract ECX, EAX, and or the D word at ECX with zeros. Learn something out. Move EAX ESP, move ESP ECX, move ECX, what's at EAX. Move to EAX, what is at EAX plus 4. Jump EAX. What the? Okay, so that is fantastic. F7, and that's a call. Here, let's hit F7. So far, this is pretty strange. Don't know why. SDAX, call deer pointer EBX. The fook. Okay. F8 that one, and then decrement EBX. It's a lot of callsing. Call this. Okay. F8. Return. Then we have another one that goes. Okay, that. F7. Okay, so we did a call. Now we're gonna get our current location and put it in EAX. There it is. And then we have a nope, and then we have another call down to there. 7. The hell? Okay, so anyhow, I digress. And if anyone's talking, I'm sorry. I can see your messages now. So anyhow, let's just go through this a little bit quicker. This is going to jump over that random string, which is just neatly tucked there. I'm going to push name, and it's going to call EBX. Now, you might be sitting here thinking to yourself, how in the hell did we know to add 0F4E9 to EBX? And that was going to be a call to puts. Well, I'm going to say dumb luck that MSV CRT has not changed in a while, because before that, this up here was setting up grabbing the EBX, the location of where those are going to be, but this is actually a local. So no, yeah, that's going to be like, if we look at this following dissimilar, yeah, so it's a local jump inside the import table there. So that's why we didn't get lucky, but it's calculating that, and then we'll see that it's going to calculate this one, and anything else that it uses is going to be calculated real time. So we're going to hit F8. Actually, I'm going to hit minus so you can see what I'm doing. And I am going to hit F8. I call that, and now we should have name. We do. Then we have a jump that goes over some stuff because, well, I probably ran out of room. We're going to hit F8. This pushes some random location, which if we follow and dump that immediate constant, and then we hit F8, it's now going to subtract 10 from EBX, which is going to be gets. We're going to call gets. I hit F8, and now it's going to say, hey, what's your name? I'm going to put in fjlj. And you'll see that, well, gets stores to an address. We gave an address, and so here's where we stored it. We called gets, but the whole point of this is so that while you're looking at it, you can't tell what's being called. And if we do search for names, and we look for gets, we'll see gets, but if we do find references, we'll only ever find this. You can't just find references to it. But if we wound back and do search for all referenced strings, you'll see that we see a yes, no, name, serial. FJLJ is now in there because it's a reference string. Serial is coming up, and then we have a yes. And down here we have a no, which is jumped to by these. And somewhere in here, it's gonna figure out what it should be. So let's hit F8. So it got our name, and now sub EBX, this big ass number, and F8, that's probably gonna be who knows what. But if we were to follow this in the disassembler, oh, we get nothing. Oh, it put us right back to this location. It put us back to our current location that we got from popping this call into EAX way back when. Oh, perfect. You're streaming now. I'm going to see it now. Haircut, bro. And yeah. Super smooth. All around. Time to have a drink. Mr. Freaking Cat, good to see you, sir. I was talking to him in the Discord. He's looking for some people that I guess are stealing my content. Alright. Problem. Alright, so now we're here. And XOR EDX, we're just going to use EDX, so we're clearing it out. Now it's going to say move to DL, the first byte of our name. It does that. And then add EBX EDX. So EBX is our location in memory. Interesting. That is 404 here. So we're going to add to that memory location. Strange. The byte of our name, which would add 66 to it. We're going to increment EAX. Test for 0. It's not 0. We're going to do it again. Move DL. Now we have a J. We're going to add that to it. Increment. Add the L on 0. And we're going to add the J, which is there. And then, interesting. We are 0, so fine. It's going to break us out. Now, watch this. Move DX, BX. DX, of course, is empty, so now we're going to move the entire contents of BX into DX, and you'll see that that is 158A. So then we're not using EAX anymore. It's going to clear EAX, ECX, and EBX. We don't need those. Move AL, DL. So there's our AA. Shift left EAX 4. So one whole space over, 4 bits. And then move CL, AL. Okay, so now CL is going to be AO. Shift right, EAX 8. So we're going to get rid of that bottom one. Shift right, ECX 4. Bloop. So now we've got those 2 A's in end. Shift right, EDX 8. So we're going to get rid of those 2 A's, move the 15. Shift left, EDX 4. Bring it over. Move BL to DL. Or no, yeah, move into BL, DL. So we're grabbing that 5. Shift right, EDX 8. We get our last one there, shift right, EBX4, and now we have 51AA or AA15 or 15AA, and now the fun begins. So, move to ESI our name. Done. It's moved. Don't care about it anymore. Now we're going to move to the first space of our name, DL. So that's going to be the 1 right here. F8, which now we have a 0, 1. And then +1 will be BL, which is going to be the 5. And then CL, which is going to be, of course, an A, 1, 5, A, jump. And then this is going to move AL, which is A. And then it's going to move a 0 just to make sure that it ends. Now we're going to jump. Move EAX, ESI. All right. XOR ESI, ESI. Compare the byte that's at EAX with 9. If it's greater than 9, we'll jump and we'll add 37. Otherwise, we're going to add 30. It's numerical. It's not a character. It's a number. So we're going to convert it from 1 to the ASCII one, which is hex 31. And we'll see this right now. See, now it's a 1 down here. And then it's going to jump over this and increment EAX. Go to the next one. Compare what's at EAX with 0. Make sure we haven't reached the end. So it's going to compare this new one with 9. If it's greater, it will go. It's not. So it's going to add that. And you'll see now that it's a 5. 1, 5. And now you'll see that this time it is greater than 9. So we are going to jump. And we're going to add 37, which would effectively rotate that A into being an A, a capital A. And then we're going to increment and do it again. So now we have 15AA. 15AA stored where our name used to be. So that's gone. And we have a 15AA. Now remember, we got that by adding up the digits of each letter of our name to our current address value, which the last few digits are always going to be the same, so that's just a constant. And then we are going to jump out because we hit the 0, and you'll see that we're going to move into EAX, the D word that's at ESP, and that's going to be 15AA. And then a call, let's hit F7. Oh look, we're going to grab our current location yet again and store it in ECX. You'll notice that it's -1, of course. So now we're going to subtract from that 8B. Oh, there's that fancy little thing that we had before, which if we were to go from right here and go up 8B times, 8B is right here, and it references this. That's why it says subtract 8B. So now it's going to jump. Let's follow the jump. Move ESI ECX. We already have it in ECX. Why we needed to move it, I don't know. Add ESI to 2D. So from ESI, which is here, add to it 2D. 2D. 2D is right here. And then we're going to jump back up. Clear out EDX. Get him out of there. We're going to move to BL, the first byte of our, we'll call it generated thing. That's alright. Okay, anyways. So we're going to move the first byte of that into BL. Bam, it's there. It's a 3-1. We're doing it. And then we're going to compare the byte that is at ECX plus EDX. Now, ECX, of course, is that thing, and EDX is 0 with BL. So we're going to look for 3-1 in this string. Jump if equal. It doesn't equal increment EDX. Try again. It's not there. It's going to be a ways. But now we're comparing 0. And now we're comparing an F. And now we're comparing a 9. Of course, you could just go, next will be a D, 7B, 8E, 1. Or you could look down right here and see what it's currently comparing. Hey, pretty snazzy. Hello, K-Log. Hi, watching from Kenya. Nice to meet you, Adam. Always happy to have some viewers, people that want to learn or just not, or just want to be put to sleep like that. I can help with that, especially when I go on these reading rants. Okay, so we're still looking. We're on the 9. We don't see it yet. We're going up to the D, 7, B, 8, E, and what's this next one? 1. All right, so it does match. Now we are going to jump. We compare DL, which is the number of times that we went through the loop before we got to the end, right? Hey, Dr. Blue Knight, what's up? Nice to see you joined in here. I'm going to write a self-keygen for fjlj crackme number 3. Right now, we're just walking through the code line by line, digesting what it's doing. We'll do it again. In case you just joined and you're worried about that, we will do it again. Especially since I'm being interrupted every 10 seconds. Okay, so it's taking the number of times we went through that string until we found a match, comparing it with 9, and once again it's going to say, am I greater? Yes, I am, because I'm a B. And it's going to say, okay, well, let's convert it to a B, and now it's a B. 42, if you don't believe me, that a B in hex, when you add 37 to it, becomes a B in ASCII character. Oh, it does, what do you know? Then it's going to move that byte to ESI. Now, of course, ESI is right here, and if we follow it in the dump, it's a boatload of nopes because it references that place that's down there, just down there. And you'll see that it's going to write a B. Increment ESI, increment EAX, compare with 0, rinse and repeat. Now it's going to do it again. So if we put a breakpoint right here, hit run, we'll land here. We'll see that now where that B is, we're going to be writing an F. There's an F. And then if we hit run again, there's a 2. And if we hit run again, There's a 2, BF22, 15AA, BF22. Now let's just stop right here. And let's see if this thing, we put in FJLJ and we put in, what was it? 15AA, BF22. Ah, what do you know? It's telling us the key all by itself because we're catching it where it's doing the calculating and it's actually storing it. So this is a perfect candidate for a self keygen. And then this time, of course, it's not going to rinse and repeat because we hit a 0. You'll see that we're going to move to EAX, this random 401606. And then we're going to pop ECX. And we're going to move a byte to ESI to finish off this string because right now BF22 is not a string because it ends with 90. Strings have to end with 0. Boom. Now it's a string. And then when we jump down here, you'll see that we push this guy and then we return. Now, a push followed by a return means that we're using this return as a jump. And if we go to, or no, if we, I just want to grab this and go to it, we'll see that it's going to put us right here where it's going to ask us for a serial. But before that was never referenced anywhere. It's not a call. It doesn't get called. No. We push that address and then we return to it. And there we are. And then we're going to start off the call inside the call to here to get, well, this address right. And yeah, we're going to pop EBX. Here we go. 401529, which is going to be here. And then we will be able to do things like this. Adding to it giant ass numbers to get random places in memory. So let's go ahead and see what it does now. Push EAX, just to keep them around somewhere, I guess. Push ECX, which of course is the first half of our serial. Push the word serial, add a boatload to EBX, and that's going to be our puts. We go ahead and put a puts, and it says serial. Then we jump up. Oh, whoa, look at that. 15ABF22 is right there being pushed. Subtract 10 from EBX. And then we're doing a gets on the address that currently holds our entire key. So instead of doing that, couldn't we just not do this? Let's do code nopes. Let's add 10 back to this, so it'd be CO. And then let's just, oh, well, it just gives us our key now. And then we could just go along our merry way. But of course, it's going to do some stuff here on some stuff and then probably crash. I pressed F8 a lot. Oh, Blue Knight, I see you made it. You logged in. Sweet. You have your very own desktop, but if you open up Task Manager, hit Users, go to Me, and then do Remote Control, you should be able to pop in and see my screen. And let's see what happens if we just let this run. Yeah, that's what I thought. It's probably gonna crash itself because we modified where it was gonna be reading from. So really, all we needed to do was go ahead and from here, instead of jump to there, just jump to return. Well, no, not return, but yeah, we can figure it out. So let's do edit, copy address, rewind. Yep. 90, 90, 90. Okay, rewind. Don't ask me again. Yeah, thank you. Okay. So you may not know where to start when you first open an application. Like, I don't know what any of this means. I always say look for exit, because if you find the exit, the shit that happens just before the exit is usually the good stuff. And if you see that, oh, this is setting up environment variables, and okay, this is setting up maybe a console, and then we have an environment variable, we have a random call here, and then an exit. Let's go ahead and go into that random call. Then, of course, this is some beginning code that sets up getting the address of gets and puts and where those are all going to be at. So it doesn't get really cool until this call right here, which goes to here. And so if we were to step through this, F9, we hit F8 a few times, nothing really happens except we get this address here, which if we follow into assembler points to here, because we just did a call here, and then we did some calculating, and then we jumped back to here in a manner in which we also have that in EAX, but we did some stuff while we were here. But that stuff is irrelevant. So now we're going to do another call to here, and this is going to set up randomness as well. So I'm going to hit F8, and you'll see that come out with 0 in EAX. We got this weird ECX, and if we follow that, well, that looks like something crazy going on too. But essentially, we don't care. Now, I do want to hit F7 on this one because it actually goes to here. And then pop EAX, well, a call puts on the top of the stack return address for the function. We're going to remove that by popping it into EAX. EAX is 0 right now. We're going to hit F8. And now we have the location of the return address for that call, which is going to be this address right here. 401 3C8. 401 3C8. Password. Didn't have to. Password for remote control. Should be able to remote view without a password. Maybe I haven't set it up yet. See. Edit. Let's see. Oh. Stop. That. Connection. Set rule for remote. Okay. Enabled. Session. There we go. Try it now. FJLJ, not reversing. Reversing is the console. And it won't let you see the console. Should be able to just right click me. Go to remote control. I'm gonna try to remote control you. Control star. I'm getting there. Yeah, I'll work on it. I haven't quite finished everything. Working on it today. Let's try probably both have to like log off and log back in or some crap. I don't know. Anyways, back to it. But yes, essentially every user can log into the VM. They'll be granted with a desktop like this, except they won't have these two crackmes here because that's just on mine. And they won't have these because I have mine viewed. Now, I have two my drive links. I don't know why I have two, but you should only have one. Yes, this is the wrong one. You should have a my drive link that takes you to your drive. Every user has their own drive. Their own desktop. Their own set of shortcuts for coding. Don't have fences put in yet, but yeah. We've got Pure Basic, we've got Olly, X32, we've got C, C++, we got JByte mod, we got the loader framework, the batch framework, exe info. I've got protection ID somewhere. Let's just go ahead and grab that. I think free tools. Put a X. Protection ID cut. And we can all be logged in at the same time doing the work. Hey, G-Master, got an account for you too. Default password is, well, password. So when you log in, be sure to change your password. There we go. Anyways, yeah, your drive, mine's empty. Maybe I should put these in there, but everybody's got their own 50 gig drive. And of course, those are, got a terabyte of space, so you're good. We got the downloads folder on the network. And we got the virtual hard disks for everybody. So if you want to take your drive with you, you can. Anything you store in your drive is going to the virtual hard drive. And if you want to take it with you, you can copy it and mount it on your own computer. They are dynamically resolved. These show up as 50 gigs, but they're not. Anyhow, let's get back to the business. Yeah, and it's super simple. Let me walk you through it. Remote desktop. Now, instead of 127.0.0.1, you'll put in the IP to the server. Those of you that have it know it. And if you don't know where to find it, check the Discord. If you got permission to it, you have an account. If you would like an account, hop on the Discord. Let me know what you want the account for, what you want to use it for. If you just want to learn to pop on there and play around, great. We'll get you set up with one. Change your username to, let's go with CA2. CA2 has an account. And if anyone needs to have pictures restored, Blue Knight is amazing at restoring pictures or colorizing pictures that are black and white. He's awesome. So you'll hit this button, you'll get this sort of prompt, or you won't. It doesn't matter, but I'm going to put in password. I'm going to hit OK, and then it's going to go ahead and log me in and prepare CA2's desktop. And boom, now we've got a fresh copy. He's got a My Drive, takes him to CA2. Everybody's got their own, and we can all be logged in at the same time. And this is a proper 8 core. I've got 10 gigs of RAM currently. That's all I had on hand. All I had on hand was 2 4 gig sticks. No, that's not even it. I had 3 2 gig sticks and 1 4 gig stick. I think. That doesn't sound right. No. I had 2 4 gigs and a 2 gig. Yeah, so there's 3 sticks in there. Getting us to 10. 8 would probably be faster with the dual channel, but we don't have a solid state or anything, so I wanted to have more for people to share. Anyhow, everybody can log in same time, play around, and eventually I'll be able to. He's disconnected. I should be able to. Why is access denied? Wait, let's try this. Now, can I do it? Hey, I can, but now it's, I'm remotely oh god. Control star. Oh god. I broke it. But the good news is, there we go. We're back. So, while you're in a local, yeah, I'll have to look at that later. Add all you want. Be cool if they would make a block to USB. Yeah, it'd be cool, but it'd be super slow. USB memory is super slow. Just because the USB bus is hampered. So then we have another call into this, which is if you're hitting F8 through all this, you're going to end up on this jump, which takes you up to exit. And that's good because what we want to do is remember this jump, Control C, and we want to control, essentially, right, was it this one? I'm pretty sure it was this one. Nope, it was this one. So if we nope this, let's just do call EBX. And here, let's do push 0. So what rest with nopes. And then jump. Come on. There. Although we would probably like to do a pause, so let's push that, call EBX. Push this. Keep doing it wrong. Push that again. LEA EBX. No, it's just sub EBX 10. Call EBX. Push 0. Jump. Exit. Not gonna work. So instead of doing that, let's edit undo selection. Control A, bring it all back up. I want to see where this is going. It's going to there. Let's grab it. Okay, we've got it. Go plus sign, minus sign. Son of a monkey, I overwrote it. Let's just scroll down this one. Yeah, let's do that. So we'll do, instead of this, we'll do call ebx, and then we'll do sub ebx 10. Then we will jump to here, because none of this will matter, especially the yes code. Here we'll need, like right about here, we'll need this. So jumps down there. I'm gonna push this again. Push that. I always do that. Call ebx. I overwrote it. Push that. Call ebx. No. Oh, yeah. That's correct. Because we're here, we'll push that, call ebx because we're sub, and then we'll push 0 and jump there. Alright, so we know that we want to do this and do that. And serial. Oh, we don't even need all of this. Grab this. Call EB. This. Not enough room for that. Sub ebx 10. Do a push. Call ebx. Push 0 and a jump. So edit, fill with nopes. We're never going to hit there. So we'll land here eventually, and then we're going to just push that. Send it. And where are we? I'm going to hit F7. Good thing I hit F7. So we're going to add EAXOF. Okay. I'm going to jump over that thing, push name. We're going to come on down here. We're going to ask for a name. We're going to put in a name. This time, let's put in, I don't know, Blue Knight. Blue Knight. Password is stored in EBX, but it's coded. Any way to just see what's in EBX? Password's not stored in EBX yet. And no, password's not stored in EBX. What's stored in EBX is just the jump table. So if we follow that, you'll see it has all of the imports and exports, and that's how the program is actually calling them, by adding or subtracting 10 to get to different functions so that you can't see the referenced calls. But yeah, if we click this and follow in disassembler, see that that's pointing at gets right now. So we did push the same place that we did name question mark, asked for input, and so right here we push name, and then we moved into EBX. What was that? EAX, which was this address right here. Then we added this value to it. That's a known value that lands us on puts. And then we call puts, and then we jumped down here. We pushed an address, just an arbitrary address, which if we follow in dump is down here. We subtract 10 from EBX to land us on gets. And then we call EBX to then perform a gets. So we put in our name, Blue Knight. Now we're on the jump. And of course, Blue Knight's going to be in EAX, pointing at the address that we pushed right here. So EAX holds this address we pushed, which is on the top of our stack, which points to this memory location right here. And so right now, it's a bunch of printable characters ending in a 0, which is a string holding Blue Knight. And Ollie tells us at this memory location, there's an ASCII string that says Blue Knight. Well, thanks, Ollie. Now we're going to jump back on up, and we're going to see that it subtracts from EBX a bunch. And then it clears out EDX to make sure it's clear. Moves to DL, the first byte of our name. Then it's going to add to EBX, which is 401, 404, which is right here. This current address. So essentially we just subtracted back off what we had added earlier, minus the amount of spaces we went, and you'll see that here. We added O4FE9, and we took off OF4AC. And so now we're going to add the ASCII value of every letter of the name Blue Knight. Increment EAX, and you'll see now it's going to go to the L. So now EAX, if we are referencing a byte, like this says here, byte, and we're referencing DL, which is this byte, L, DH is here, so we got DL, DH, DX is both, and then EDX is all. So if we're referencing the byte that is at the memory location held in EAX, and we want to put it in DL, we know that that's an L, and F8 will put an L there for us. And then we're going to add to EBX EDX, which means we're going to add that L right to here. Boom, what do you know? We're going to continue doing this until we hit a 0, which means we have gone through every letter in Blue Knight. Because once we hit a 0, we're at the terminating, the null character, the string terminating character. So we can breakpoint right here and hit F9, and we'll see that we have 1831 sitting here. And let's watch the magic happen. DX gets BX, 1831. We clear out EAX, ECX, and EBX. We move to AL, DL, so AL is going to get 31. We shift left EAX 4, so now we have 0. Now we're going to move into CL, AL, so we're going to get that 1 down here. We're going to shift right EAX 8 to get rid of that 1 and put 3 here. Boom. Now we're going to shift right ECX 4, so we're going to put the 1 at the end. Cool. Then we're going to shift right EDX 8, and we're going to get rid of the 3 1 and have 1 8. And then we're going to shift left EDX 4. Boom. We're going to move into BL, the 8. Boom. We're going to shift right edx by 8 and get rid of the 8 and have just the 1. And then shift right this one to have the 8 over there. So now we have 3, 1, 1, 8, and of course they're not in the right order. What is this doing? I just explained what it's doing. So it took what was in. Let's go through it again. So stop right after name. And oh shoot, I don't want to do that. So we'll go over it again. Promise you that. But what it did was it took every letter in the name Blue Knight and added it to value 401,404 while it was in EBX. And then it cleared out EDX, moved BX to DX, I believe. Yep. And then it isolated each digit of those last 4 digits, what it grabbed. After adding the name to it, it's grabbing those. Now it's going to write those. See that here. Move to ESI, the byte that's at ESP. And that's right where our name is. Move DL, move BL, move CL, and move AL and a 0. Okay, so we've got that string of 1813 written down here, but now it's going to convert those to the printable ASCII, and to do that it's going to need to know whether it's a number or a character. If it's a number, it's going to be 9 or less, 0 through 9, and if it is 9 or less, it won't jump, and it will add 30 to the value there and give us a 1 instead of a hex 1. Now we have an ASCII 1, and now it's going to do it again, and it's going to say, all right, we've got an 8, so we are going to do an 8 and a 1 and a 3. None of those were characters, but if they were, it would add 37 and do the same thing. Who is the guy I'm... Ha! Oh no, the beard is gone. Yes, the haircut, beard. I went into a barbershop. Hey, a guy walks into a barbershop looking mildly Middle Eastern, and he comes out looking European. I don't know. And so now we see 1813. And let's go ahead and see what happens here. This call is going to go right down there, so don't hit F8 because you won't land there. You'll skip all the way over it, so F7 to go into it. Pop ECX. We're grabbing that value so we know where we're at. We're at 401,464 plus 1. So sub ECX 8B. That gives us our magic thing. Jumps down here, moves that, jumps back up. And now it's going to search for 1813 in our little magic string and tell us, you know, the number of, essentially the position that it was found in is what it's going to report back. How many times did we have to go through the loop before we found the character in it? And there we go. Now this time, the character it was b times, because 1 is b times, so it's going to add a 37 to it to get us a b. And then it's going to move that byte into ESI, and it's going to just be forgotten forever. But let's follow ESI real quick, follow and dump, and you'll see it's down here. Increment, do it again. Now, how many times do we have to go through it to get an 8? Well, 2 less times than we did to get a 1. There you go. And is it less than 9? Yes, it is. So we'll add a 30 to it, and then we're gonna jump and we're gonna write it, and that's a B9. Oh no. And we're gonna do that a few more times. I held down that button a lot longer than I thought I would. Damn it. Okay. So let's just slow down and back it up a little. Okay, so we got to here, and that finished our B9, B1, and put a 0. Then we jumped to here, we pushed this value, and then we returned to that value, which is here, so, damn it. 401524, 524, which was here, and that was called here. We push EAX, push ECX, push this value, which is not correct. Did a call to get? I broke it. This is going to be a call to gets, but it didn't give us what we wanted. And then it's going to jump to exit with push to 0, so that's great. Because it does exactly what we wanted it to do, but I screwed it up somewhere. We done went haywire, alright. Alright, so let's do this. We're running Blue Night. Alright, so here's, you wanted to see what it was doing before. Here we are. We have this EBX and EAX. EBX is just this value of where we were at. And we're going to add to EBX every ASCII value of each character in the name. And once we get to here, that is complete, and you'll see that we have 1831 in the end of EBX here. And then it's going to move into DX, which is empty, BX. So DX is the last 4, and BX is the last 4. So we're going to move those up there. And then we clear out EAX, clear out ECX, clear out EBX, and we move to ALDL. So now we've got the last 2 characters, 3 and 1. We're going to split those apart, move this one over, move that one over, get rid of those, split those apart, move that one down, move that one over, move that one over. That's all it does. What's your question? Always ask questions. If you're interrupting, I won't read them. The only interruptions is when I get zzz, zzz, zzz. Okay, and then it stores those, and then it converts them with this fancy guy. That will end up here. I want to hit F9 here. There we go. So pop, jump, 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 jump. F9. Okay. So now we've completed that. Move EAX this random value. Pop ECX. 1813. We know that that's part of our key, and we're going to follow it and then dump. Move byte. Okay, we're just making sure that ESI is now a string, because that's the other half of our serial. B9, B1. And then jump, push a value, turn, call, pop EBX, push EAX. Okay, so what is EBX? Don't care yet. Okay, then we're going to push ECX. I'm going to do that. Push ECX. And this is going to ask for the serial. And you'll see now that we have EAX and ECX. And that's our 1813 B9 B1. So this is going to say serial. This is going to be a puts. Just thinking how we can do this, because we could just not push that and then call this twice. Okay, so we're going to say serial. We're going to jump up here. Then this address, follow and dump, immediate constant, is this guy. This is going to be a get, so let's just go ahead and do that. Okay, got it. I see. Is this crackme 3 file best done in olly, or is it so? How do you tell? I don't want to, but just thought. Is there a better way? So olly and X32, they're basically the same. They just have different functionalities. In the beginning of the stream, I was talking about why this time we're going to use olly, and it was so that I could do things like this. Right click, help on command. This says loads double word from the top of the stack, memory pointed to by ESP, to the 32-bit register EAX, and increments ESP by 4. Very easy to understand that that's going to take this value right here, put it in there, and then the top of the stack will be here. Whereas in X32, this is my biggest gripe about X32 is the help on command button that I used so much when I was first learning, and I still use it today occasionally, is garbage. It was severely neglected. Severely. Just find a pop. No, I don't want. So let's do a pop EAX. Help on mnemonic. Now, instead of getting a short little blurb that says, hey, we're going to take this top of the stack and throw it in the register and then move the top of the stack, you get this. Which, for me, is overwhelming. I'm like, where's the pop? Where's, all the way, I gotta scroll all the way up top because it just dumps it in the log. Pop a value from a stack. That's all it could just say that. I mean, then you get this long ass description, which this is pretty much all it should say. Loads the value from the top of the stack to the location specified with the destination operand. But instead of saying the destination operand, it should say EAX. And so for this specific crackme, I wanted to be able to say, well, what's this do? Up on command. Performs bitwise XOR. Okay. Command XOR EDI zeros register EDI. Oh, cool, thanks. Thanks, Ollie. But they're both disassemblers, they're both debuggers, and they're both laid out almost identical. But the help on command definitely missing in x32. So where were we? I think I was about to rewind this, actually. Yes. We are star. Okay, about to put in a serial, then it will break. 1, 2, 3, 4, 6, 7, 8, 9. Okay, so instead of saying serial, we're gonna say edit unfill with nopes. This is to get to puts. So yes, we want to move this up. X fill with nopes. Push EAX. Call EBX. Push ECX. Call EBX. Push 0. And jump to exit. Up there, I want to jump to this, I believe. It's this one right here. Oh, I just need to move XOR EBX and then jump. Oh. Edit. Copy to executable. That's not what I want to do. No, I want to do edit, copy. I want to copy all. Crackme 3.1 keygen. I want to hit run. It's gonna break it. So this is gonna be running. It says name. This one's not. Get out of there. Okay, so this one's running. It says name. Now let's put in CA2. It breaks here, of course. And let's go with keygen and let's put in CA2. And I forgot the gets. Okay, so let's grab another olly. File, open. This guy. And down here, where we do all that fanciness, push ECX, EX, EX, XOR, and jump. Not quite yet. We want to do. Grab that. I'm going to do a sub EVX 10. Do it. Wait. Edit. Oh yeah, it is EV. Okay. So sub EBX 10 push EAX all EBX XOR EBX jump. CA2. Well, we got the B024, and then we got some garbage. Let's go on down here. A2. Alright. We're here. F7 puts us here. EAX does not yet contain it. Follow and dump. Yeah, it does. Yeah, B024. F8 puts. ECX gets fucked. See that? Oh. Be right back. I don't always drink wine, but when I do, it's from a stemless wine glass. Oh, I see. That does. My old messages. I'm back. Kids are back too. Badly bye. Okay, so ECX gets wiped out. That's not going to work for us. EBX, however, is not. ESP is not. Let's use EDI. So, for that, do edit, binary copy, edit, go with nopes. Move ECX, no, EDI, ECX. Binary based. That's not correct. FO. Something to be aware of if you ever do binary paste. It will change the address because it's copying the actual binary opcode. And if you move it, well, it's going to reference a different place. Okay, so we moved EDI ECX. We're going to push EAX, call EBX, push EDI, call EBX sub 10, push EDI, because it will still be reserved. Call gets, and then XOR, and jump to the exit. Edit, copy to executable, and if you don't follow, don't worry, we're going to go through it. Let's hit run. X. Okay, name CA2, and we're paused. Keygen CA2. B02414AF. I feel like that's backwards. Actually, I know it's backwards because 1 is B, 4 is O. I know those. So, we'll rewind this, and it's a very simple, easy, practical fix. Not scrolling down into oblivion. But down here where we have our patches, instead of moving EDI, ECX, we'll move it EAX. And here we will push ECX. There we go. EA2 breaks here. 7. Move EDI, EAX, push ECX, call, push EDI, call, do a gets. So now we have 1 for AF. This one's frozen. Run. Go. 1 for a F B 024. Yes. Ah! And of course, when we hit enter over here, it's going to close. So, let's quickly. I do need to sleep. Always. Story of my life. Always got to go to sleep. Close that. Rewind this. Just to crack me. Oh. Hey, MBR Tech. Master Boot Record Tech. But what about GPT? Kind of want to eat the key. Am I connected? Am I talking to nobody? Yeah. Okay. So, welcome back. So, the beginning of a code. Also, how does the exit work? I'll show you. Okay, so anything you want to know from this go through, put it in the chat and I'll try to touch on it. Other than that, I'm going to just be walking through the code and yeah. So the beginning of our real code is right here, and I'll tell you right now that this is a bunch of boring stuff to figure out where we're at, just to get down where our jump table is so that we can make calls without having them be referenced. That's why everything is call EBX. It's either call EBX or call the next line. So the first bit, just ignore that. That's like a whole other video. So then this one, this call calls the next line, then pops the return value, which is this line. This one then calls here. This jumps to exit, but this will never get called, I don't think. Because well, maybe. But down here, if you remember, we do a push return. So jump being used as return. So let's begin. Let us begin. So this is going to call here. That's going to go to here. This is that. This will never get called. F9. Okay. So we're on add EAXOF. Okay. Now EAX is currently holding the C8 address 4013C8, and that's from this pop EAX. Grabbed the return value of this call and stored it in EAX. And then it made a new return value by calling this line, which tells it to return to here, which is, in fact, the only way that we can hit this jump is if we hit this return to exit the program. And if we hit this one at any time, if we end up here, this is going to do a call to exit process. Now, exit process takes one argument, and Ollie's telling us that right now. It takes an argument called exit code. Now, exit code 0 is success. Exit success, it meant to exit, we're good. And if we notice that it's putting to the top of the stack, EBX, this is, ouch. I'll be right back again. Oh boy. Okay, so this says no matter what is in EBX, we're putting that on the top of the stack, and that's going to be the exit code. So I know that if I want it to be return success, it has to be a 0. So I'm going to make sure before I go there that there's a 0 in EBX. Okay, so we are here. We're going to add OF to this address, which is going to put us at this address. See that now. So D7, we have caught up. We are now following the current pointer, or the EIP matches EAX. So there's jump over some data. We push name, then we do some fancy subtraction on our table we worked out, and we call EBX for puts to say name. We do a call, we push an address, we subtract 10 knowing that that's where gets is, we call gets, and now we have give academy. I'm gonna put a space in it. See what happens. Oh, it cut it off. Give academy. Oh, you're not far behind. What do you mean? Oh, that means you're probably the only one still like wanting to learn and push forward, is because you're the only one asking questions. Everybody should be asking questions. I ask questions. The only way to learn is to ask. Get your questions answered. Then we're going to jump back up. Then we're going to subtract from EBX this number to catch us back up to our 404. We're back at our current location. Why that was important? Well, I didn't really do it, I guess, but now this is where it gets tricky, because if we look at EAX, you'll see that it's actually give academy, but this is only going to here for whatever reason. If we do a control A, it might fix it. There we go. It does. So, add EBX, EDX, and EDX holds the A, or I mean not the A, but the G in AL, or in EAX, the first byte. We're going to add all those up onto the end of EBX, which starts out as 401, 404. And we're going to hit F9, and we see that after we do that, we have 4018A3. And then my younger self said, okay, how do we want to make a serial out of this and then test against it? And I said, well, I don't know, older self. I guess I'll just grab DX and I'll use these four as the top half of the serial. And I went, okay, that sounds reasonable. Let's do that. Move DX, BX, bam. So then I had to figure out what in the hell am I gonna get all of those into ASCII characters from the registers. Like, I don't have these anywhere in memory. I only have them in the registers. And my younger self said, well, I got it. We'll clear out a bunch of registers. 3 other ones, because we're going to need 4. And then what we'll do is we'll take the bottom and we'll put it in AL. All right? And then we'll shift the whole thing up 1 bit, or 4 bits. to move it over one character so that we go from A3, it'll be 3-0 in AL. And I went, how do I do that? Shift left. And I said, okay. I typed in shift left, and then I read this. Shift logical left shifts the contents of 32-bit register EAX 4 times to the left. For each shift count, most significant bit is shifted into the C flag, and the least significant bit is cleared. Flag O is also modified, but according to the specifications is defined only for single bit shifts. It is set to C, X, or bit 31. All other flags are set according to the result. If shift count is 0, flags remain unchanged. Synonyms: SAL. Note that all Windows capable processors shift count is taken modulo 32. Mod 32. So, 32 bits. And we go back to here. So I said, okay, we figured it out. We need to shift this left 4 bits. Boom. And then I can isolate the 3-0 by just moving AL to CL. So I do that. And I say, okay, now I got to get rid of this 3-0 and leave just the A. I'll do that by shifting it right twice as far as I shifted it left. Boom, I have just the A. Well, now we got to clean up this ECX. It's not 3-0, it's 3. We'll shift it back 4. All right, we got the 3. So instead of 1-8 A3, we've got A3, and now we need the 1-8. How am I going to do that? I know. We'll shift right EDX and just get rid of what we already used. And then we'll rinse and repeat. We'll go left. We'll move DL to BL. And then we'll go right. And then we'll go right. And ta-da! My younger self said, I've done it. I've isolated all 3 of those, and now I can convert them to ASCII by simply adding or subtract, or adding 30 or 37. And then I said, crap, now I have to store it. We'll store it in the place that the name was just at. Alright, so what order? We could mix it around now if we want to. I'll just do the standard order. DL, BL, CL, so that's going to be ESI, ESI plus 1, plus 2. So DL, BL, CL. Crap, I'm out of space. I'm going to run into this code. I better jump over here because I didn't write things in order. And then AL. In BASIC, it was common to do 10, 20, 30 line numbers in case you needed to go back and write something in between. Yeah. So now we're going to write AL, and then we're going to write a 0. So now we have a string, but it's not a string yet because it's non-printable characters. So then we're going to jump into this loop. It says move into EAX this garbage, clear out ESI. Compare it with 9. If it's greater, we'll jump over. It's not, we'll add 30. Bam! Now we got our 1. And then I increment to the next character. Rinse and repeat. Compare the byte that's at EAX 9. Oh, girlfriend. Where is my tray here? What the there we go. I think I will be more behind you. I'm just starting out. Cool. Cool that you're starting out. Everybody should start out. So it says it's an 8. It's not greater, so we'll add 30. It's an 8. We'll jump, we'll increment EAX, moving us to the next one. Compare what's there with 0. It's still not 0. Let's do it again. We'll compare what's there with a 9, which it is now a 3, so it's still not greater. Boom, 3. Jump, increment, come back around. And then the next character, it's a A. Is it greater? It is greater by 1. We're going to jump. Now we're going to add 37, so we get an A. increment EAX, compare it with 0. Yes, the next byte is a 0. We're going to jump out. So now we have 183A. And then we do a call to the next line, but if you fall for the trick of pressing F8, it's going to put you somewhere, because this push return, it's not going to put you here. So F7 puts us here. We're technically inside a call. See how we have a return address here? Well, we're about to pop that into ECX. And now we don't have a return address, and ECX has it. And then we're going to subtract from ECX 8B, which means we're going to reference 8B, this magical string, boof, there it is. Oop, there it is. And then we're going to jump down here, where we move to ESI ECX. We add ESI 22D. So from that address, 22D down, ESI, follow and dump, references some random space that we can always write to because it's not write protected. Then we're going to jump up into here and say clear out EDX, move into BL, the first byte of our key. It's a 3-1. Search through ECX plus EDX until you find it, incrementing EDX every time so that we know how long it took to find that one. We all know that it takes B times, or 11. Oh, look, we're at B. Compare DL9. It's more than, so it's going to add 37. It's then going to write that to here. We have a B. Now, let's watch that one more time, because now it's going to increment ESI to this spot, the next spot. Increment EAX, so now we're going to be referencing the 8. It compares the byte to make sure we're not at the end of the string. And then it goes back on up. XOR EDX, clear it out. Move to BL, next byte of our name, 38, which is an 8, and it's down 9 times, I think. And we keep going until we jump. Just looking for that 8 in this string, incrementing it forward. And there we have it. So it's at 9, compare DL9. It's not greater, so we will add to it 30. And then we will write that right here, B9. Increment ESI to the next position we're going to write to, and increment EAX, the next character we're going to reference, and keep doing that until we land here. And then we see we have B912, but there's no 0 on the end yet. So we move to EAX, the 401606, which is the address that it starts at. We pop ECX, and then we have incremented ESI already to be the end of it. So we're going to move a 0 there, and now it is a string. And if we do a Control A, we'll see that string in EAX, because now olly can recognize it as a string. We jump over to this, we push a random address, and then we return to it. And go. And then that call is going to put us here. And then here, of course, it's going to ask us for our serial. We're pushing EAX, pushing ECX. We're getting those on the stack so we don't lose them. We've calculated what the serial is supposed to be. We've put them on the stack so they don't get lost. We're going to push serial. We're going to get some magic so we can get our puts. And then we're going to call puts. It's going to return how many characters are written to the screen or whatever. It says serial. We're going to jump up to here, and then we're going to push this address here, which is out in the middle of nowhere. Subtract, and we're going to do a gets. And of course, we could put in the correct serial. And let's actually do that. 183A B912. Then it jumps back down. Clear out EDI. Pop EAX. So now EAX will have whatever we typed in. Pop ECX, which is serial, just the string. So I pop it twice to get the first bit of the string. Then pop EDX. And then compare the byte that is at EAX plus EDI with 0. Now EDI is 0. The byte at EAX plus EDI is 1. Compare if equal, increment EDI. So at this point, it's counting how long the string is. Greetings, how it going? Oh, nice. Look, got rid of some hair. Yeah. Yeah, I look real creepy now. Have a glass. Cheers, DSP. Where have you been, sir? Like there's a bug crawling up my collar. Oh. Ugh. It's been so warm, windows have been open. Bugs are flying in. So, yeah, it looks like we're just getting the length of our typed in serial. When I do crackme 3, I get a password of 15AABF22 is what you get if you type in FJLJ. Absolutely. And I can demonstrate that with this keygen that we made. FJLJ 15AABF22. But if you type in blue, you get 15CABFC2. Got my drink here too. I've been around trying to get a job, the usual. So get a job! I'm just kidding. My buddy just got a job as a help desk technician at a place. Okay, so now we've got it. We've counted it. We're going to move to ESI EBX. That's our get. So we're going to clear out EBX. We're going to compare EDI with 8. So that's the length of our key that we put in. If it's greater, we're going to jump to the node, the bad boy. If it's not greater, move BL, the byte that's at ECX. Now, ECX contains the first character, well, the byte reference, contains the first character of our actual key. Compare the first character of our actual key with the what's in BL. Now, we put in BL. Oh, I'm sorry. Move to BL, the first character of our actual key. Then compare the first character of our typed key with BL. And it says, if that's not equal, jump to no. So the first character that is wrong, it will jump to no. It's not, so now it's going to increment EAX, increment ECX, compare the byte that's at ECX with 0. Jump if not equal, which means go back to here, because we want to check and see if we're 0 at the end of the string. We're not, so we'll come back here. And then we'll move the next byte of our actual key into BL. What, you need to go outside? What, you need to go outside? And then we will compare the next byte of our typed in key with BL. And if it wasn't matching, we would say, get out! But if it is matching, it increments EAX, increments ECX. You see them up in the registers here moving. Now we're at 3A, 3A. We compare with a 0, we do it again. It matches. It matches. And since that last one was a 0 in ECX, we're not going to jump. But now we'll go into move ECX EDX. XOR EDX. Compare CL0. Jump if not equal. So now we're going to move back up and do it again. Move BL, the next byte of our real key. Compare it with our typed key. If at any point it's wrong, go to no. Increment and go until we hit a 0. BL, compare those. Compare ECX, which ECX is our real key, with 0. And it's not taken. So that tells me a couple things, but we'll see what happens. So move ECX EDX, XOR EDX, compare CL0. It is, so we will now say yes. Add ESI 10 to get puts. We'll call puts. We'll subtract ESI to get gets. We'll call gets. And that will say yes, waiting for us to hit enter. Pop EAX. Pop ECX. Clear out EBX. And then return to the jump. Goes to exit. It's very artistic. But, you want to see something cool? What was that key? Edit, select all. Grab that. Let's rewind. Oh, what was the name I did? Give Academy. Okay, so let's rewind. Now this is a theory, but I think it will work. Let's go give Academy. Hit run root off. I want to paste. Now, I know that it tests the length, so if it's more than that, it would just throw it out. Damn it. Well, I'll patch that because I want to say fuck or something at the end. And then, of course, I don't have it patched, so. Compare EDI 8, jump greater. Edit, copy address, rewind. Oops, rewind, not X. Let's just edit, binary edit. I'm just patching this to where it doesn't care about the length that I want to test. So give Academy. Give a cat to me. One 8 3A B92. Okay, run. I do want to go into here. Actually, this one, right? Yeah. Do it. Okay, so paste. Not that. 183A B912 sup. Okay, so now we're here. And you'll see that, yes, our key that we typed in still has lots to go. But since I wrote this, doing it off of the compare with the real key, it's not going to care. It'll get all the way to the end because it's checking against ECX, and it's going to say yes, even though sup is still on the end there. So if we didn't test for this length, you could potentially get the right key and then append whatever you want on it. Now, what happens, because this follow and dump, what? Oh, program is running. G 43ECD4. So we've got a bit of room here, but what if we typed in something that long? Or actually, what if we typed in super long name? Because Give Academy started here, and then we're going down to here. Prepended would not work. This program is set up for other functions. Months in there. What do you mean? Months? Sure, I follow there. Prepended wouldn't work because it does check from the beginning of the string. But postpended. See months in the program. What do you mean? What do you see? Where do you see months? Under ref strings. Find search for all reference strings. Oh, these? Who knows? Just compiler shit. Yeah, it's just compiler stuff. Never used. Yeah, I don't know about all that stuff, but probably libraries that were included but never used. Anyhow, so I say to all of you, learn by doing. When I started reversing, I started picking up, okay, this does that, this does that, this does that. Well, how could I do this? How could I write a loop? So you all should take out of downloads, not that downloads, computer, downloads, tiny, T, no, not T, tiny base, desktop. So, should all grab out of desktops. I'll put it on everyone's. I will put it on everyone's desktop right now. Tiny base, X, computer, C drive, user, desktop. It's gonna be public, desktop. Boom. Continue. All right. An executable called tiny base on your desktops. Tiny base is this. So edit, fill with nopes. It's a program that starts there and ends down wherever you tell it to end, and it has nothing in it but nopes. I challenge you to write something. Let's see here. So if you need any data, Gonna need to come down here and be like edit, binary edit. Name question mark. 0 there. Serial question mark. Edit, copy address. Come up to our beginning here. Push, bam. Call puts. That doesn't work. Call user 32. No. Where is puts? Kernel 32. MS. No, it's msvcrt.puts. Well, see here. Search for names. Aha. Yeah, you're also gonna have to go ahead and import some stuff. Do search for all intermodular calls. There are none. So let's try follow and dump, immediate constant. Go down here. Let's go. Where is puts? Puts. Put S. C. Puts is in. Come on. Puts. MSDN. Puts. There we go. And it is in all versions. Well, that doesn't help me. Grab another olly. Open fjlj. What the hell? Oh, that's public desktop. My desktop. MSVCRT. Puts. Oh. See if that works. May or may not. Oh. All right, well, now the fun begins. So we'll need that. Let's grab this, edit, binary edit, insert, this has got to be a 0, puts, space gets, do we call load library? Call load library A. Yes! Okay, so now instead of pushing name, we need to push msvcrt, edit, copy address, push that. Call load library. Ah, Jesus, what the call load library A. And then we need another one. Nope, we're good. So then we can do push. Let's see. I don't remember if it's handle then name or name then handle. So it's handle then name. Push EAX. Push 401 0. Puts. Edit. Copy address. Push that. Call get proc address. And then we want to do push 40109E call EAX. All right, let's see if it works. Hi, hey Vegas, good to see you. So let's see if this works. We want to push MSVCRT, load library, yay. We got a handle returned in EAX for MSVCRT. We're gonna push that, then we're gonna push puts. And if I did those in the right order, which I did not, so let's pop, and let's go put these in the right order. That, push, golly, ollie. New origin here. Okay, let's try that again. We're gonna push puts, then we're gonna push the handle, MSVCRT. We're gonna call get proc address. Boom, we got puts in EAX. We're gonna push our name, boom, and then we're gonna push it, boom, and we're gonna check and see if we wrote name. I don't think it worked. I don't worked. Let's go edit, copy all modifications, executable. No. Not the public. My desktop, tiny base, save. Yep. Rewind. Push MSVCRT, load library. Push that. Proc name that. We have a handle to puts. We push a name. Call puts. Return value 0. I don't think we have standard. Oh, this is FJLJ crackme 3. What the? Oh, we don't have a console yet. We have to spawn a console. Let's see here. That is going to be. What is it? I think it's get command line. Get command line. That's in kernel 32. Let's rewind. Do call get command line. New origin here. Yeah, a wild console hasn't appeared. Boom. Maybe now it has. Nope, that's not it. Want get console. Also redirect. How? The on console. On console process. Done this before. I could search through my snippet probably faster than this. Oh, that's freaking stupid. Alright, bear with me. I gotta search through some snippets real quick. Driving text search console. No, not the name of it. Containing text console. Oh, there it is. Alec console. Where were you guys at on this one? Alec console. Boom. Now we have a console. The origin here. Okay, so now we're going to push MSVCRT to load that library. We're going to push puts. We're going to push MSVCRT. We're going to call get proc address. We're going to push a name, and we're going to send out a puts to our console, hopefully. And look, we printed name. Hello, world. So. Oh, color the text. No. No. No, I'm not doing that ASCII colorized stuff. But I will do edit. Wait. Binary copy. Console. Binary paste. Edit. Undo selection. MSVCRT. Load library puts. Boom. Boom. Name. Boom. Edit. Copy all modifications to executable. Exit. Yes. Tiny base. This one is going on the public desktop. Because now, that's more than enough for you to be like, okay, so it's going to allocate a console. Boom, we got a console. Okay, now I had to reference data, and I had to write that myself in my file for the library I wanted to use, which is called MSVCRT. And then I loaded a handle of that, although I just fucking broke it. Okay, these calls need to be fixed because I copied, pasted binary. This is load library A. One is get proc address. Rewind. Okay, there. Sorry. I'm wondering why crackme 3 when opening up an olly there's a command window. Of course there's a command window that opens for crackme 3 because crackme 3 is a command prompt crackme. Of course it opens a command prompt. Anyhow, so now we're going to allocate a console. Boom, we got one. MSVCRT. Oh, I thought you opened it. Nope. Nope, you did fine. In blank. Yeah, of course it comes in blank because you got to see this one that we just made. It's super blank because it hasn't output anything to it yet. So now in this little tiny base we're saying I want to load MSVCRT, and if I was a smart guy I wouldn't keep that handle in EAX. I would edit, gonna break everything, binary copy, go with nopes. I would move ESI EAX so I always have that handle in ESI, and then I can do binary base and do I'll get proc address. Get proc address. There we go. So we have the load library A. I'm going to move ESI, the MSVCRT, so I have it for next time. Say I want to grab puts. So now we're going to push puts because that's the name of the function that we want to get out of the handle that we're pushing to the stack now for MSVCRT. And then get proc address says, all right, I'm going to scan this handle over here for puts. And when I find it, I'm going to return it in EAX. And then put says, I take one command only. You give me a string and I'll output it to this here console. And I'm going to make this a little smaller just so we can seize that interaction. So here you are. And of course we put it on the stack as an argument. And as soon as I hit F8, boom, it gets written. And then of course if we wanted to do gets, well, we don't have EAX anymore because, well, that's not there. But now we could do push some random location, say 40103C, except we can't do that yet. So X, we want to push the location of, oh, come on, damn it, of gets. Follow and dump, immediate constant. Gets is here. Scrolling to move it. Push 401OB8 gets, and then I want to do push ESI call get proc address, push that, call EAX. Boom. You'd have to click. I haven't watched since the beginning, but I'm guessing based on other things I've debugged that once the crackme is opened, it will get to a pause. Might not get to the name part. Exactly. You'd have to click play till you get to it, but it should since. Well, usually, I mean, it depends on where it's set up to pause. What the? What did I miss? Lemon! Lemon has subscribed. Thank you, Lemon. Welcome aboard. Almost missed it. Okay, so next we're going to grab gets. We're going to say gets ESI MSVCRT. Can I have it? It says, yes, you may. And then we're going to push this random memory location, which most likely is going to crash our program when we try to do a gets to it. Here we go. It hasn't yet, so it's waiting for input, fjlj, but as soon as I run, I think it will crash. Aha! So we have an access violation because we just tried to write to memory that's not writable. And then it will crash. Not a writable address. However, a quick call to virtual protect with that address on there, we could change it to where it is writable, and then we could do it to there. You are my best life. Well, thank you. Thank you for joining. And yeah, so if you don't have an account, pop on Discord, get yourself a desktop on the server, and just start learning. And if you want to do a loop, let's do a loop real quick. We'll find this. Let's go with nopes. Let's do a XOR EAX, EAX, XOR EBP, EBP, and then let's do inc EAX. I don't know why I picked EBP, but it'll be fun to watch. Dec EBP J. Let's do a test EAX. No, we'll do compare EAX EBP jump if not equal 401004. So if we analyze, we'll see that we have clear out EAX, boom, it's empty. Clear out EBP, boom, it's empty. Increment EAX. The coding train is good. Yeah, dude, I love Dan Schiffman. Great guy. Increment EAX, decrement EBP. Compare EAX and EBP. They're not equal. And we're going to continue this way until we meet in the middle. We can hold this down forever. Or, yeah, I held it down a little long. If we double click here and hit run, we should stop because, well, there is going to be a point where these match. Eventually, boom. And we'll see that they both match at, well, it should be the halfway mark. Signed and unsigned. Same number. And so that loop said, you know, compare EAX with EBP and continue to increment EAX by 1 and decrement EBP by 1 until they match. Do that forever until they match. So if they never match, you're going to be in that loop forever. But once they do match, continue on. That's all there is to a loop. I mean, you can do whatever you want in there. You can do a counter. Say we want to read these bytes up here. Let's do that. Let's go call 40100E. Nope, F. This is technically calling its own line now. F, there. So E8 followed by 4 zeros, well, eight zeros, 4, you get what I mean. Means call this line. Well, then I want to do pop EAX. Let's clear out ECX. And let's clear out EDX just for fun. And then let's subtract from, we should have this place here. We'll subtract F, sub EAX F, OF. Go. So let's see what happens. So I'm going to hit F7, not to screw myself over trying to F8. So we'll land on this pop. And that's going to put the OOF into EAX. And then I'm clearing out ECX, clearing out EDX. And I'm subtracting OF from EAX. Now we have the beginning. Yeah, I'm more than happy to increase the font size. Usually we're in 720p. If you are on mobile, you're probably having a hard time reading this. Whoa! Let's go option. Oh golly, what the happened? Regular 12. What in the hell? Alright, it's good enough, whatever. Okay, so now EAX points to right here. Now if we wanted to read all of the code that we have written, let's do that. Let's say better things to you. Yes, just super bold. I'm not sure why it's like fonts, system fix font. Shit. Ooh, pretty good. There we go. I like that. There. I quite like that. Oh, that's odd. It's like it changed the letters as right? It was weird. Hashtag it's the little things. Okay. So now what we're gonna do is put into ECX what's at EAX plus EDX, and then we're gonna increment EDX. So let's move ECX, the D word. Yeah, that'll be okay. Now let's make it simple. We'll do byte at a time. At EAX plus EDX. And of course, it's going to say conflicting data size because we said byte instead of D word. So that wouldn't be ECX. It would be the byte version of the register, which is CL. Boom. And then we want to go compare CL. Actually, we'll do increment EDX, compare CL OF. Actually, no, we'll compare it with 8A. Jump if not equal to 401017. Symbol. Okay, so we got a call there. We're going to move into CL, a byte that's at EAX plus EDX. So EAX plus 0 is EAX. Going to point to the 3-1. And we move into CL at 3-1. We increment EDX. Compare CL with 8A. It's not. So we're going to move the next one, CO. EDX, compare it with 8A. Nope. We're going to be able to see byte by byte what's in our program all the way up to the 8A, which I did just because I knew there wasn't any more 8As, and that's the beginning of our code. But we could have it read inside this loop, the loop itself, and beyond. So let's change this 8A to 90. Yeah, it's 346 and I'm tired. Compare 90, nope. And what we're doing is we're watching this read every single byte of our code. Where are we at? Oh, 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 5, 8, 1, 9, 1, D2, E3, E8, OF. Now, what happens when it starts referencing its own place? Absolutely nothing. It doesn't care. Like, all right, yeah, I'm reading the next address that I'm executing. Care. 42, yep. So now we're reading into the future lines of code. We could now go, okay, if this, somewhere in this loop, we've just read a byte past our own stuff, so we're on 80 now. If we then here did compare ECX 80, we would know that we're here and that it wasn't modified. So, for example, if we put somewhere in the loop of a calculation somewhere that, you know, this F7 was still an F7, otherwise jump past that, you know, we could technically, theoretically, write redundant code that looks ahead to see if the code has been modified at all. Technically. Because it doesn't care. It'll keep reading forever. As long as you don't try to make a change. See, now we're on 90. Because the 90 is here. And it is going to match. And no matter what, once you get to that byte, unless you've stored it in a register, for example, if I say compare CL with DL, then do move DL CL, well, that's going to increment past all stuff. Let's do compare BL, move BL, and then jump if not equal 401.7. That should never match. Well, unless it's 2 in a row. See, we hit 2 in a row. 90-90, which we are now here. Anyways, let me get some rest. Can't piece. Yeah, so this has been a pretty good little stream. First, we went over, you know, how the crackme worked, which is downloadable in the Discord. If you haven't joined Discord, join Discord. The link is in the description. Tear it apart, look through it. Now, I do want to X32. Excuse me, I want to do crackme 3. I want to see. Go ahead and run. Crackme 3 there. Let's go to cexit above it. Go and analyze. And then, can we graph? There you go. So, here you can see oh, we got that, and then a jump, but the graph actually isn't too helpful on this one because it's not seeing all of the stuff in there. But yeah, if you are in the Discord, just send me a direct message if you want a login for the server, so you have your own desktop to do all this in. It has everything on it already. And then, yeah. Basically, I just wanted to pop in here and see what the graph would do, or would look like for now. And we went through how to turn it into its own keygen. It's here. Any name. Oh boy. Why are you awake? It is bedtime. Okay, go that way. kids, I tell you. Hey, 7 Oda XP. Well, you just popped in. Use my desktop. Oh, yeah, it's like, what the fuck when you... Oh, yeah. Anyways, yeah, we looked into this, made it into its own keygen 16DE ED6A. Yes. And then we just talked about some assembly programming for a while, how to do that, and what's not. Then we made a tiny base that just says name and then crashes because, well, access violations. And for those of you that are just joining, I'm going to end it. It's going to post itself up. You'll be able to watch the whole thing from there. And of course, if you have the login information, feel free to jump on into your own desktop and play around if you need help. I'm still working on it, but I should be able to go to remote control. Wait, what did I say? Remote control is disabled on that side. It's connected. Star, does this work? No. I'm still working on that. I had all the kinks out once, but then I reinstalled everything because, yeah, I thought I broke something that I didn't. And then all the Windows updates took forever. And now we're up to date, so that's good. One thing I need to check, and that's concurrent. This one. Yep. Okay, it's patched already. Okay, so everything's good there. I'm going to go to bed. Do you guys have any quick questions before I take off? Because I have to be up in about 4.5, 5 hours to take the girls to daycare. And I'm sleepy. So, quick questions and answers. And I see 9 of y'all are watching. If you did just jump in, you'll have fun watching the video from the beginning. Be sure to pause it when you have questions. Go back, read through it, and tell me any questions you can think of later. Of course, we'll get people into the remote. I'll walk them through it while I'm viewing what they're doing. Let you do some hands-on learning. I believe it or not, I enjoy that more than doing it myself, just because I would rather teach a man how to fish than to give a man a fish. And on that note, hopefully I'll see you guys tomorrow. Bye.